Hello. In this video, we're going to be solving these equations, and notice that in each equation that the unknown is in the exponent of the equation. So starting our problem off with number 13, notice that both sides of the equation have a base of 3. Now on the left side we have 3 to the x, and on the right side we have 3 to the 2. So if these two things are truly going to be equal, the only way this happens is if x is equal to 2. So we can kind of solve that one intuitively, and we have our answer, right? If we put 2 in for x, then we have 3 to the second equals 3 to the second. Pretty simple. Number 14 then. Now 4 to what power is equal to 16? Now again, you might be able to just intuit this and say, well, clearly 4 squared is equal to 16, so you can tell me that x is equal to 2. But another way to look at this is to say that 4 to the x is equal to, and then we can change 16 into also having a base of 4. That's 4 to the second. So then your bases are the same, so now the exponent has to be the same, so x would equal 2. Okay, in 15, we have 5 to the x equals 5 to the 2x plus 1. Notice that whole 2x plus 1 is the exponent. And so, again, same bases. So for these to be the same, we need our exponents to be the same. That x would have to equal 2x plus 1. And if that's the truth, then we just solve for x. So subtract 2x on both sides. So negative x is equal to 1. And so if negative x equals 1, then x must equal negative 1. And there's our answer for 15. To do 16, we need to clean up the left side a little bit because we have two parts multiplied together. Both of them have the base of 6. But when we multiply with like bases, we add our exponents. So I can look at this as 6 to the x over 2 plus x over 3. And to solve this, or to simplify, we need to get a common denominator. So if I make this denominator 6, the smallest number that 2 and 3 both go into, I'm going to take on the left side top and bottom times 3. And so we get 3x over 6 plus, and then the other one, the top and bottom, will be taken times 2. So we get 2x over 6. And that's still equal to 6 to the 4th. So we know then that once we combine like terms on the top, 6 to the, well, 3x plus 2x makes 5x. 6 to the 5x over 6 is equal to 6 to the 4th. Well, what that means is that because our bases are the same, that 5x over 6 has to equal 4. So then to solve, we take both sides times 6. So the 6 divided 6 will cancel. We get 5x is equal to 24. Then we divide both sides by 5. And so x would equal, and we'll leave it as 24 over 5 since the fraction doesn't simplify. And there's my x value. Next, in number 17, we have 49 to the x equals 7 to the 3x minus 4. Now these do not have like bases. So I'm going to do something similar to what I did in number 14. I'm going to change the 49 because it can be rewritten as a base of 7. 7 squared, in fact, is the same as 49. So we have 7 squared to the x is equal to 7 to the 3x minus 4. Now that means we have 7 to the 2x equals 7 to the 3x minus 4. And since our bases are the same, now our exponents need to be the same. 2x has to be the same as 3x minus 4. And then we solve for x. So subtract 3x on both sides. So negative x is equal to negative 4, and x is equal to 4. Okay, we'll do this again here in number 18. Same concept. We don't have the same base. One is 1/11th, the other one is 1 over 121. But I can rewrite that 1 over 121 as 1/11th. Now 1/11th to the second is the same as 121 because 1 squared is 1 and 11 squared is 121. And then that whole thing is being taken to the negative x over 5. And that's still equal to 1/11th to the negative x over 2 plus 1. So I'm going to run out of space here. We can take our power to a power, so negative 2x over 5 is my exponent on 1/11th. And on the other side, 1/11th has the exponent still negative x over 2 plus 1. So then we set those equal to each other. So negative 2x over 5 is equal to negative x over 2 plus 1. To make this easy, because 5 and 2 both go into 10, I'm going to take both sides of this times 10. So 10 divided by 5 is 2 times negative 2x, we get negative 4x. 10 on the next part here, then there, so I did that one first and now this one. 10 divided by 2 is 5 times negative x, we get negative 5x, and then 10 times 1 is 10. So I will add 5x on both sides, and so x is equal to 10. All right, number 19. 2 to the negative 2/3 is equal to 8 to the x over 3 over 4 to the 4/3. So I'm going to turn everything into a base of 2. So let's start. We already have 2 to the negative 2/3. That's equal to 8 is the same as 2 cubed. So we have 2 cubed to the x over 3. And then the bottom, 4 is the same as 2 squared. 2 squared to the 4/3. And so we clean this up here. 2 to the negative 2/3 is equal to 2 to the third to the x over 3. Well, 3 divided by 3 is 1 times x. We get 2 to the x over. Then on bottom, we have a base of 2 still. My exponent of 2 times 4/3. I can't divide 2 by 3, but I can take 2 times 4. So 2 times 4 makes 8, and we're still dividing by 3. What I'm going to do now is take both sides times 2 to the 8/3. So that these will cancel, and my right side will just be 2 to the x. And the other side, we have a base of 2, and we are multiplying. So we add our exponents. So we have 2 to the 8/3 minus 2/3, plus that negative 2/3, but minus 2/3 is what's happening. And 8/3 minus 2/3 means we have 6/3. And I'm bringing this here. So 6/3 is the same as 2. So 2 to the 2 equals 2 to the x. So x must be 2. And we're done. So most of this was just trying to get the bases to be the same, and then we could set the exponents equal to each other. Okay, for now we are done.